So here's our scatter plot. And notice, compare and contrast it to the Excel one, it looks the same. Excel is prettier. Excel is prettier, of course, because it actually has color and it's got labels and things like that. But you can see what you're looking at. You're looking at your time as your independent variable, that's x, in seconds. And you're looking at your distance in feet as your dependent or y variable. Now, one thing you do not have to do this. You do not have to do this at all. You don't have to do this at all. But one thing I like to do, it's kind of hard to see the first data point, the 0, 0. He's down there, but he's kind of buried on that axis. So one thing that you can do is you can go, and only if you want to, you don't have to do this, you go to the window button and you can finagle the numbers that are in here. Like, because when you hit zoom 9, that zoom stat menu, it picks the window based on the values that you have in L1 and L2. And I'm not exactly sure what it does. Like, it takes an x scale of 1, which is fairly logical. That's 1 second, 0, 1, 2, 3. But it takes an x of negative 1 point blah, blah, blah. So I like to just go ahead and clean that up a little bit, make them a little more integer. So I'll make them like negative 1 and 13. I'll try to make it match the graph we had up here. And then as far as the y's go, the y mins at negative 34. That's 34 feet before I started. 0 is at the top of the hill. Negative 34 would be 34 feet behind me. I don't see much of a reason to look at that. So I'm going to make that 0. And it's called my maximum distance 234. Well, I know I maxed that at 200. So if you want, you can go a smidge above that so the point doesn't get cut off. So I'll go like to 210 maybe. And this one right here is the one that kind of gets annoying, the y scale. Did you notice when you look at the graph, it's a solid line, it's a solid like thick axis. That's because for whatever reason it decided to put the axis at 0.1 increments. Exactly. So 0, 0.1 of a foot, 0.2 of a foot, 0.3 of a foot. That's silly. Let's scale it by tens. 10-foot increments make a lot more sense. There. Now every time you see a dot, it's 10 feet. 10 feet, 20 feet, 30 feet, 40 feet, 50 feet. You can also go even more, you go by 20 feet if you want to. It doesn't matter to me. 25 feet. If you go by 25 feet, that'll actually sync up with perfectly with the data points, because you guys are measuring at 25 feet. Let's just do, you know what, let's do that. Let's go by 25-foot increments.
And that's for the y scale.
That's y scale. Yeah, that y and x scale, SCL, all that is a way of putting the dot, the tick marks on the axis so that you know what they are. The problem with them is, and this is just unfortunately, we have to live with this with the TIs, there's no markers. There's no markers on the axis, so there's no number like there is in Excel where I can put distance, feet, 0, 50, 100, 150, 200. You can't do that on a TI. The best you can do is have that picture and then have the dots, and you in your mind know what the dots mean. Does that kind of make sense? And I'm hoping you talked about this in your previous like Math 95 class, but you may not have. You may not have. Cool? Now you can see, it's still kind of hard to see this little guy down here, but he's there. The first data point is 0, 0. And if you want to see him more, you don't have to. If you want to see him more, drop that y min negative. Although it doesn't make sense, you'll see the point a little bit more, but he is kind of hard to see regardless because they put him right on that axis. Okay, I'm going to put it back to 0. Okay, now in class on Wednesday, I'm sure you forgot this, and that's okay. We put a linear model on top of this. Everybody do a linear regression right now. Store it to y1 and graph it with this data. So in other words, treat this like last lesson. So stat, calc, I want to go kind of fast, hope you don't mind, but you get your little booklet to walk you through this. You write your booklet. 89's behaving itself, right, Shelley? Good. Lin reg, stick it in y1.
How do you stick it in y1?
Put y1 next to it.
Put y1.
Bars right, enter. Third page, first paragraph.
Thank you.
You're welcome. And this does give us some information. This does give us some information, which we'll come back to momentarily, I promise you that. But go ahead and press graph and take a look at that. There's your best fit line. No, well, hang on. I just said there's your best fit line. Nick said that sucks, and we're both correct. Huh? We're both correct, aren't we? That's your best fit line, and it sucks. Because this data is Not linear, it's quadratic. Thank you guys. Whoever said not linear here, thank you. That's Andrew. And it's quadratic. Bruce, thank you. So I'm not saying that linear modeling is terrible. Because it's not. It's that it's incomplete. Some things are not linear. Some things behave other ways. So sometimes we have to add to our toolkit when something does not look linear. So linear, and I did a quick graph of this a couple classes ago. Linear modeling is when your data kind of either looks like this, or it kind of looks like this. Where you've got a predictable rise or predictable fall. In other words, as you move across the x-axis a certain fixed number of units, the y-axis changes in the same predictable fixed number of units way. And that's linear. That's what makes it linear. That's why you have a slope. That's what a slope is telling you. A slope is telling you this many y's for this many x's. All the time, no matter where you are. And that's fine for certain things. And it's terrible for others, like my speed on a hill. So now we're going to add to that quadratic modeling, and on Wednesday we're going to add to that exponential modeling. We're going to keep adding, and then we're going to stop. Because there are totally different kinds of modeling besides those three. But I discovered that Math 105 students don't care about them all that much, and that's awesome. Because although they're important, I don't think it's important to force you guys to learn them. Now, quadratic modeling can look like one of two shapes, because you guys learned this in your previous math classes. Your parabolas can look like this, can look like that, so it's a U shape, or they can be an upside down U shape, something like this, reaching a max point and then dropping off.
Like throwing a ball in the air.
Like throwing a ball in the air, or a projectile of some kind, something along those lines. What are we looking at here with our data? Green or red parabola? Green, definitely. Now, and this is important. Everybody, let's rerun the model. Yes, we have time for this, then we'll take our 5. Rerun the model, not as a linear one, but as a quadratic one. So, in case you're wondering where that is, stat calc, you got it. Stat calc, just like linreg was, but he's number 5 instead of number 4. Quadrag, the one right underneath him. And you do him the exact same way. You drop quadrag down and definitely put y1 next to it, because I want to graph it with the data. So vars right, enter, enter. Vars right, enter, enter. Nothing's different except you're picking quadrag instead of linreg. Everything else is exactly the same. That's the beauty of having the booklet. All you've got to do is keep track of the 3 different models we need to use. Fair enough?
It just looks much better.
And it does, because it's now it looks like a smidge more confusing. Just a smidge, because you now have one more constant there, which we'll talk about after your break. But when you press graph, check it out. And you might recognize that fit, because it's the same one I had up here in Excel when I did a polynomial order 2. Order 2 just means that the highest power is x squared, which you saw back on the home screen right here. But that is a much better fit.
John?
Yeah?
I got a red parabola.
You did, but that implies something. Let's come back to that. Benji, what he did was he read a logarithmic model.
Yeah, I did.
You ran a log model, ln?
I suppose.
ln reg. Which number did you run?
I did linreg, then I did quadrag, and when it looked like exactly what we got on the board when I did the linreg, and I did the quadrag.
Let's chit chat. You got a row data point somewhere that's pulling it down. That looks like a logarithmic regression where it goes like this and kind of starts flattening off. Let's chit chat at the break and find out what the hell's going on, because it should. There's only one best fit parabola, and that's it. That's the best fit parabola. It's not perfect, is it?
No.
It's not perfect. It misses some of the points. It misses some of the points a little bit. But it's the best fit to the data. Now, you do not want to extrapolate with this too much. We'll come back. We'll come back at the after the break, because you guys are getting that glaze like you want to take a break. There's a limitation on using this that I want to make sure we get across, just like there's a limitation on lines, an assumption that we have to not make. We'll come back after the break. I see a lot of yawnings and a lot of glazed eyes. Take 5, come on back.